Good morning and good afternoon, everybody. It is 12:30 Central. I'm your host, Bill Murphy. Welcome to Tech Talks webinar. Our technical talks today is Mirafi webinar. It is Mirafi. Tencate Mirafi host or guest Jim Golomski is with us. I'll introduce him here in a minute. And I am Bill Murphy, and I'm clicking on this webinar to make sure I can move the slides. There we go. I'm representing ASP Enterprises, Quick Supply Company, Bowman Construction Supply, and Cascade Geosynthetics. All of our companies have been in business for decades. We average over 45 years of experience in most of our companies, and we have well over 12,000 customers in our database now across the country, and we'll show the map here next. We have over 40 technical sales professionals inside and outside. We have a number of CPESs on staff, and we do have one professional civil engineer available to help with project design, product selection, and then just education in general for our staff and yours. And I am active in a lot of the organizations we're a part of and do as many presentations as I can. You got me looking off screen because I got a couple monitors here for the first time in my home office. Our 9 offices are located from the Midwest across the Rockies out to the Pacific Northwest. Contact your local ASP, Quick Supply, Bowman, or Cascade rep if you have questions, or reach out to me. And you can also reach out to our guests directly. You're familiar with our erosion control and sediment control solutions for sure. We do like to continue to educate folks on geosynthetics like we're going to do today. A lot of my time is spent on stormwater management with green infrastructure and low impact development. We're also experts in vegetative solutions, and some of our locations even have hardscapes available. We are experts at logistics. One of the things we found as a challenge over the last couple of years, and we've been blessed to stay on top of it, is inventory management and receiving product in time to get it delivered to a job site. One of the things we're very good at, and I'll show it in the next slide, is receiving truckloads of product, breaking that down to exactly what you need on your job site and delivering it when you need it, where you need it. We've been blessed to be essential over the last couple of years, so we've been very, very busy, and we plan to continue that trend. I was recently asked a question by a very good friend of mine at an engineering firm in Kansas City if we have any concerns about product availability with the Mirafi products, and I was very happy after I double checked with our managers to say, no, we have no problem at all. We've been blessed, and that those trucks are still rolling. So winter doesn't stop us. We've stayed busy. And as many locations as we're in, the pendulum swings sometimes from one market to the other. One thing stays constant. There's a lot of people trusting us with their site solutions, and there's a lot of people who have been with us for many, many years. And speaking of many, many years, our next speaker here is in the room already, Jim Golomski. Jim is with Tencate Mirafi. I've known Jim for the 8 years I've been with this company and a little before that. Jim is one of the professionals that we lean on whenever you have questions for us, and he represents a number of our locations. I did not write down Jim's bio. I have known him for a very long time. Jim, not to embarrass you or anything, you know that we have a good personal relationship and a good working relationship. I sometimes like to as a guy with football experience and college experience, but mostly for me, it's that you're a family man with professional experience, and I get to see you again this week at Geo Omaha on Friday. Do you want to introduce yourself at all and add anything to that?
Yeah, that's perfect. That pretty much covers it.
1234.
It's what?
1234. I hurried through.
Yeah, right on time. No, perfect. Thanks, Bill, for the introduction. I guess one thing that we could start out real quick. I don't know how much longer I'll be using the side that says Tencate Mirafi. We merged with a company called Solmax. Tencate did in 2021. So I'm guessing very shortly we're probably going to be called Solmax Mirafi, but Mirafi seems to be the name everybody knows us by. So as long as that stays, that's good. So yeah, I've been in the industry over 15 years, doing geogrids, geosynthetics, fabrics, and 11 years with Mirafi and ASP and Quick have been partners where the entire time I've been in this industry. So, like I said, engineering business manager out of Kansas City. As you can imagine, we got a lot of snow overnight. So kids are home from school. So let's hope I sufficiently threaten my son to stay off streaming Fortnite for the next hour so that we don't have any hiccups here. So with that said, we'll get started. And like Bill said, this is going to be it's an introduction to geosynthetics, and it doesn't matter where I go. There's a huge range of what everyone knows within the products. So we'll give you a brief background of what they do, why they're important, and where they're going. And I think maybe the simplest, easy analogy uh, to geosynthetics is because everybody just says a fabric's a fabric, but you really got to think of these things more like iPhones. And the first generation of an iPhone, you could make a phone call on. I don't even remember what else you could do, but then you could take pictures or play games or the apps and you name it as the evolution goes on. But these current phones are, you can make movies on now compared to the first one. Well, our breadth of products is very similar. Some were made, as you can see, in the
Oh,
industry.
you know what? I forgot to give you the remote control. Shame on me.
Oh,
There,
Bill.
you got it. I think you have it now.
Okay.
Yeah, that's you, buddy.
So there we go. So as we go, I want you guys to think these products are all made of polypropylene. They're 15 feet wide by 300 feet long for most of them, just from a standard stock, but they have vastly different properties and they do vastly different things. So if we can stop thinking of, a flip phone to the iPhone 13 with fabrics, we can start using these in the proper context and having more success with them. Because at the end of the day, it's a widely used product in industry, but is still always huge opportunities for it to grow. And when put in the right application, these products can always make your project shine. So just real briefly, everything got kind of started in the U.S. back late 1920s. Fibers used in swamps, but that's still not really our industry. The spunbound came about in the 50s, and our products are these needle punched. Now I'm going to see if I can move my face off the screen. Oh, there we go. The needle punch nonwovens appeared in Europe, and that's what the Mirafi products are. All of these came out of the cotton industry in the US, so down in the Southeast. And that's basically where we were with nonwovens. There we go. Then Mirafi was named. If you didn't know the name, we get a lot of Mirafi. Mirafi comes from the names Miracle Fibers, was coined a little bit in the late 60s. First used in a dam, and then really, so non-wovens, which we'll talk about, really were the only product that existed until this time. And then we get slit films, wovens. Ours are called the X series, but they're slit films, and then monofilaments. And this is where the term geotextile came from. The monofilaments are our product we'll show you that was really developed with and in conjunction with the United States Army Corps of Engineers for use for engineered erosion control to be able to have high flow rates and high separation of products. Then in the early 80s, many of you might be familiar with biaxial geogrids, came over from Europe. And then Mirafi came out with high performance woven geotextiles. So if you're familiar with that, it's our HP series, HP 570, very common. So we've gone from non-wovens to slit films. Now we get biaxial HPs. And then the markets kind of stayed a lot the same way until modern day. In 2010, right when I joined this company, we came out with our RSI series, an integrated geosynthetic. And then a few years later, our Mirafi H2RI. So that's pretty much our iPhone 13. If Bill, maybe correct me, is that where we're at in the iPhone world anyways? I don't know.
I think that's right.
I think we're somewhere close, but that is the most modern thing. And as we go, something eventually is going to become better. I don't know when, because we've had a lot of breakthroughs in these last 2 years, but I'm excited to tell you more about these products and show you some case histories and applications that we've used. So going back, the original product, the one that we started showing, and here's what all ours looks like. Ours is called the N series. And these are non-woven needle punch fibers. All of these products, like I said, are basically polypropylene that we make in our plants in Georgia, extrude the yarns, punch them, and create them. And non-wovens are definitely the most common product out there in the market. And ours they're basically described by weight. So a 4-ounce non-woven means 4 ounces per square yard, approximately, and we'd call that 140N. So you have all the way from 140 to 32-ounce non-wovens, but common in the market, you see 4, 6, and 8-ounce non-wovens used every day from French drains, wrap drains, erosion control, and cushioning layers. In the environmental world and landfills, you start seeing the 16, 20 ounces much more common. And that really just packs a whole lot more fibers into a square yard. So all of these, and we'll talk about it more, as you want to make a geotextile stronger, you have to add more fibers to it. Excuse me, I'm going to pull that up. And the more fibers and strength you pack into each square yard, the lower your flow rates get. So for example, a 4-ounce non-woven will not be nearly as strong as a 16-ounce non-woven, but it will have much greater drainage properties. The 16th will have greater filtration properties because there's more fibers in there to separate materials. But they're very good products. These are the ones, I'm sure it's very similar, if you'd feel, to the back of an old couch. But you've seen them for landscaping fabrics to, basically like those industrial applications I was talking about. So when you use these, very high flow rates mean your water really gets to flow through them. Great job filtrating, keeping soils and rock from intermixing, and they will elongate, which comes big if used under riprap or erosion control, because you want the fabric to maintain intimate contact with the soil, and you want that riprap to hold the fabric down in place. That's really the goal as that system works, is you want the elongation of a geotextile in those type applications. So disadvantages, very low strength to weight ratio. You don't want to use these in soft soils to stabilize roads and platforms or lay down yards, access roads, you name it. In the wrong applications, they could choke off or blind, but it's rare, but it's a situation where we'll kind of discuss going forward. So that was the first product and the most widely used. Here's what they kind of look like. This is the stadium in Minneapolis. These products go under all kinds of turf fields nationally for their drainage and separation properties. Very easy kick and roll type install processes. Obviously, the heavier they get, the heavier it may be, but who knows? You're probably looking at somewhere around a 6-ounce here, plus or minus. But just going down separation of materials, and that. Here's another very common is that pipe's going to be backfilled. So they cut a trench, laid the fabric, they'll wrap it in rock, and then burrito wrap on top with the non-woven geotextile.
I love that the burrito wrap is around the clean rock and not just around the pipe itself.
Right. That's a very definitely good point. So yeah, the goal is going to be whatever, if soil, who knows what gets put back on top, but to keep that rock separated so that water can flow through that rock section and into the pipe. So after that, then the next, and I believe our slide said it came around 1980, is a product we call X series. For us, 500X, 600X, other people call them STs for slit tapes. Very, very common, one of the largest selling products of all time. And I'm also here to tell you our worst product. The industry, we have definitely evolved industry-wide away from these products. And if you want to think about the manufacturing of this woven, it's much like a cassette tape yarn. So very flat yarn woven very tightly together. So what you get in this is separation. You can separate materials, but you get very, very poor water flow, which we'll talk about. And they're also very slick. And they're also weak as far as woven goes. So due to the manufacturing process, it's the best you can really get out of slit tape yarns. It was the best thing you could do from a woven 30, 40, I guess that would be 1980, 40 years ago. So that's why they were more commonly used. But definitely technology has affected the woven products much, much greater than the non-wovens. And so here's where you start seeing the evolution of geosynthetics within the wovens, because these things that we're going to talk about, properties that make them go, tensile strength, flow rates, frictional capabilities. I mean, if we're going back to an iPhone, this is like talking about camera increases in a phone, your ability to take pictures and video, storage, all these things where the phones can look alike, but the capabilities and performances are just dramatically different. So X series also something you've seen as a weed blocker. You can get a thinner version of it at, say, a Home Depot. Do not want to use these for stabilizations, especially where water is a concern. You can imagine if you put a product that doesn't allow water, very, very little on top of a wet subgrade, put rock on top of it and start driving it, you'd get that water bed effect pumping because the water wants to escape the subgrade and it can't get through the fabric. But the fact that it's ripped, it's either going to pump or it's going to rupture that fabric because it's weak as well. So hopefully I've sold you on never using the X series unless you are in a very dry type area with very minimal traffic, maybe somebody's rural driveway that has water runoff capabilities on the outsides of it, where water won't be that issue, and you really are just looking for a lightweight separator. At which point, Bill, what would we tell people to use?
Well, we could use that X series. We have some other things I'd rather use like RSI or H2RI.
Yeah, well, that's going up, but if it's minor, I'd still would then, if you just want that lightweight
Yeah.
separator, I'd just go with a lighter weight non-woven. I would use the 6 ounce there for a similar
We
price
we
point.
have we have a ridiculous amount of 140N, 160N, 180N available at all times. That is a product that moves every week, all
Yeah,
year long.
yeah, and it's
Or
going
not,
to be it's going to be effective because it's going to separate and it's going to flow,
our
right? It's
non-wovens
not
are
a
very
high
popular.
strength reinforcement, but it's going to take care of the two most important properties.
I laughed when you asked me because my family asked me if I really needed HP series under our family patio, and I said no, I could have gotten away with something else. But even at work, they tried to talk me out of it. I over design everything.
Yeah.
Uh, I love it. Not to try to oversell. Just as an engineer, I'm overly cautious. So that's why we like to ask you and our sales team to help bring some reality to it.
Yeah. I'm shocked that you overthink things. So, but Bill does bring up a good point. As we get to this, and I hope we get to the end, and when I talk about our new engineered products, you're going to say, that's the best product. That stuff's amazing. It's better than everything else. I should use it for everything else. Well, really, that's where our engineering discretion takes hold, right? Yes, that would be great to have that, but do I need that, right? We want to give you the tools, knowledge, and then be here to help so that you're buying the least expensive product that's going to work for 100% of your project. So hopefully that's the other thing. You'll see I'm like not talking bad about non-wovens because you should use non-wovens probably over
Yep.
half the time for your applications. But there's other half you should be using something else.
And I will say on a daily basis, our inside sales team, they rarely even have to ask the outside sales team for advice or ask you manufacturers for advice because they're so familiar with what the day-to-day projects need. And our contractors are pretty well educated as well. But I love this Geo 101 so that people don't feel threatened like they have to oversell or overdesign.
Yeah. Yep. ASP, wherever you are, has a lot of good resources. And then at the end of the day, they can kick it to me. And
Yep.
at the end of the day, if I can't, we have professional engineers sitting around doing designs that I can go to. So to
That's
always
awesome.
help with any type project. So going from the X series, what really changed is our HP series, and it completely changed the yarns. And if you just look at those, pictures, you can see it's a completely different weave type pattern. That is those yarns. And so these products are more articulated with depth and ridges, and the water is able to move through them. So with these new yarns, the new frictional component, we get a much higher performing polypropylene fabric. We get medium to high permittivity. Permittivity, you're going to hear a lot. Once again, that's our water flow. And what it means, medium to high here means the highest strength HP fabric has medium flow rate because there's more fibers packed in that square yard. And the low strength HPs have high permittivity. There's very good tensile modulus to these products, meaning high strength and low strain. They're very good for soft soils and roadway type applications. I don't know if I got more on some of these because of our pictures. Let me see if I can move my pictures. Okay, and then there is, I guess I'm glad I moved our picture so I could see MSE walls. Where you might hear these, especially in some of your rural areas, is our HP 570 is part of the FHWA spec for what's called the GRS IBS. It's the geosynthetic reinforced soil for bridge, what is it, something bridge systems.
Yep.
And it's layer after layer after layer of HP 570 built for bridge abutments in rural areas where you don't have to do big concrete foundations. So there is specs on those. It's a 4,800 pound tensile strength spec. and the HP 570 fits into there. So what do these products look like? Here's a classic installation. This would be an HP job. Going over soft soils. You can see there in the center of your screen, that would be an overlap. It's always good to touch on overlaps. Always 1 foot side to side. If you're in very poor soil, sinking, which I'll show you some pictures of, you can be up to 3 feet. But here it is, placing rock on top of the fabric, back dumping, someone is dumping the rock, and then this guy spreading it out as you go. You can drive on it. If you can't drive on the soil, you can't put fabric down and then drive on that. So just know that being said, the fabrics work by interlocking, confining, and tricking rock into thinking there's more rock than there's actually there by its ability to keep it in place. Confinement, reinforce, make 8 inches feel like 16 or 12 like 25 is really the whole goal. So when using these for stabilization type projects, there should be a huge cost savings versus natural instant rock in place or putting rock in place to get equal performance. And we have design software that I'm not going to touch on Geo 101 today, but it is there for designing either paved or unpaved roads. Just real briefly, we'll touch on filter weave because it's a very common practice in Nebraska. This was the one that I talked about with the Corps of Engineers. It's a woven monofilament with very high permittivity, not tensile strength. So here's something common. I know the ASP group in Omaha has used quite a bit of this over the years for blowouts on the backsides of the Missouri River. Engineered product, very, very good because each hole is engineered detailed to a specific size to keep soil and whatever's on the other side from intermixing. Here it's like a hard armor type system. But these holes also allow that huge water flow, which you can imagine is very important for any tidal or channel type application. Here's where you would go look for a filter weave, versus a non-woven for like erosion control type projects when it's tidal or water type conditions, and clogging could be an issue long-term on a non-woven. So that's all of these products are the geosynthetics world. We're talking about Geo 101. That was geotextiles, wovens and non-wovens. And now the other half under geosynthetics comes geogrids. And so there's 2 types of grids, either uniaxial, we'll say, or multi-axial. Uniaxial, very common. These are your walls, your slopes. Geogrid having high strength in one direction. For us, and common in this industry, this is the one exception where it's not 100% polypropylene. These are polyester yarns coated in PVC. Polyester from a purely tensile strength has a much higher strength to weight ratio, and you're able to get a lot of strength out of the polyester grids. So that's the product we sell. Mirafi XT is the product name, and I'm just going to touch on that. Strength in one direction. So if the wall wants to fall this way, that force has to be going back into the wall. Like biaxial geogrids can be laid any way. Anything I'm kind of showing you can be installed. It's pretty idiot proof. This stuff, if you would take a layer of the grid and put it perpendicular to the wall strength-wise, your wall would fall down. So this is one that installation is very critical on. And like I said, high strength to weight ratio, very good walls and slopes. Then staying in geogrids is biaxial, been around since the 80s, bidirectional, tridirectional. I'm sure you hear now, but these are quoted polypropylene type products. I don't think there really is any more polyester biaxial geogrids on the market. I can't think of them. But these products are very good, very high strength to low strain. Applications are soft soils, roadways, foundations. So the one big thing that we talk about with these products is separation, separation of fine soils with aggregates on top. So if you really want to use biaxial geogrids and soft soil applications, we tend to advise, and actually the industry does on CBRs below 3, of placing a non-woven fabric underneath the geogrid, or going up to an HBRS type series. So we kind of started. So now this was kind of the basic overview of some of the products, but this is what we're looking for, that properties that define a geosynthetic. And they can't all do everything. So separation, ability to keep the soil and the rock from intermixing, filtration, that ability to allow the water to pass through, from that wet subgrade through the fabric into the rock section and not trap itself underneath there. Drainage, which is the in-plane ability to allow the water to move itself out. And then confinement, and confinement really is done a lot of ways. On a fabric, it's done through friction, 100% friction and coverage. On geogrids, the confinement is done really, if you look at those holes, right, those apertures where you get rock strike through, and then that builds that matrix of rocks on top of those apertures and confine so that rock can't laterally move. And the same way then with a fabric with reinforcement of putting that in-plane tensile element pulled tight so that it reinforces that entire zone or road. And so it'd be great, as this industry has gone along in the evolution of products, well, what can the products do? And we just talked about non-wovens, the filter weaves for erosion, the slit films, geogrids, and high-performance wovens. And what are they doing, and where do they excel at? And non-wovens, right? Separate materials, filter water, drain water, but they're not going to be great for building with. Very similar to the monofilament. Really, the monofilament is the engineered version of a non-woven. Slit films, separation, that's it. And we get a little bit of reinforcement, maybe if it was a really high strength slit film. Then geogrids capture the other side of this equation, confinement and reinforcement, but they don't do any filtration or separation of particles that can't be naturally filtered. And finally, the high performance wovens. So all of these, and this is variable because it varies on the flow rates of the product. So this brings us to 2010 and the industry dilemma of, well, what fabric should I always use for what dilemma? And one product cannot do it all. And what it led us to. And so here's something we talked about earlier, and I said, no matter what the product is, and so as you go left to right, tensile strength, that's 2% strain is the criteria. And you see that you start adding material to each of these products and you start adding strength. Well, I don't know if we can give an award. This works better in person here, Bill, but
yeah,
what decreases, is there anyone in the Q&A? What's going to decrease as our strength of these products increases?
I think that there's not, I haven't seen any Q&A on anything yet.
Maybe you can give someone 8 extra PDHs if they answer. I know it's super difficult to answer questions.
It is.
Format.
Unless we did a poll, maybe we'll evolve to having the poll where they click on something.
That'd be nice.
I'll make a note.
Yeah, I was starting to think, did my Wi-Fi go out? Is anyone here?
No, you're good. Is this thing on?
Yeah. I'm going to hang up and listen. So here's what happens to flow rates as the tensile strengths go up. So we added material to the square yard, we add cost to the square yard, but we add strength, but we start losing flow rates. Well, some of you might say, who cares? Who cares? So let's take a look at a study. Moving my picture again.
You're sliding on your display. You're sliding your picture.
Yeah, that only affects me, right?
Yeah, it only affects you.
Yeah.
And you're handling the lag like a pro. There's sometimes a 6 or 7 second lag from when you click it, but you're handling it very well.
Okay, yeah. So I'm doing that. Sorry, my picture always ends up where I'm trying to look at something. So this is a test they ran, and we have a CBR of 1. For those of you who don't know, a CBR of 1 is one of the lower strength soils that we can be talking about. At a CBR of 1, you are probably out walking in this and you're sinking to your ankles. That's how poor of a material this is. Your shoes are definitely sinking into the ground. And when we test products, and quite often we're on sites like this, you want to test them in these type conditions, not only because they shine, but they're absolutely needed. to bridge some of these materials. So that's what we're looking at. And what we've done here is they've decided to take a test where they're going to cycle through products and try to get a rut depth. On the bottom right, you can see our products are 600X, which I hope you remembered. I said is a long time product that you should never use unless, you know, a few type criteria. So poor flow, poor strength, poor friction. The BX 1100, so the gray is that control section on the far left. And you can see, and this also speaks to any geosynthetic in a soft soil is going to benefit you. It's just a matter of which one you should use. Next, after the 600X was the Geogrid, the BX 1100, which is a very good product, very good confinement. But what's clear is happening here is you are going to get at a CBR of 1 that mush underneath coming up through and interacting with the rock section. The more interaction you get of soil coming through interacting with the rock, the more the rock acts like the soil. And then we have HP 270 and 570, and this really confused our people because prior to this, everybody's always assumed more strength, more tensile strength, greater performance. And these two products came in neck and neck. And so this led to the next question asked, which is flow rates and getting back to it. So why does it matter that a product can be stronger and perform weaker? Excuse me, going back one. So our X series products only allow 4 gallons of water per square foot per minute. Our HP 570 is 30 and our HP 270 is 50 gallons. So it's that free flow, that ability of water to move within it and not get trapped into underneath it, which is helping with these deformations. So here's the pore pressure development when they tested 600X versus a very light HP 270. And you see a dramatically less pore pressure developed underneath the fabric and within the subgrade, leading to rutting and deformation. And so then they developed this prototype product, which we'll now get into, to capitalize on the strength benefits of the HP and the flow rate benefits of a lighter HP. And so you put those same CBRs, terrible CBRs down, and you can see how much better, more than double the performance this HP 570 hybrid, this prototype is. And then we brought that to market. Then we're going to get into next. It's called the RSI series. So there's two true real problems now as we're going to start talking about utilization of these products within roadways, you name it, or structures. There's separation of materials and there's moisture issues. And first, we're going to really concentrate on separation and strength. So if you don't have separation between your soils and aggregate layers, you're going to lose aggregate into your subgrade just during construction. It just happens initially. You're going to have infiltration of your subgrade fines into your aggregate base, and then you're just going to have a dramatically reduced structural capacity of that road. I've seen so many things depending on your CBR. You can lose up to 20% of your aggregate to initial construction in a CBR of 2, and 20% of reduction of your rock leads to close to 40 to 50% of your carrying capacity if we're looking at easels. And then moisture, on the other hand, the problem with moisture within your rock section or your structure, excuse me, is it reduces the shear strength of your soil. It reduces the strength modulus of your base rock and increased damage from freeze-thaw cycles. So here's the newest generations of our fabrics that incorporate everything. Tencate Mirafi RS series. So 10 years ago, this came out, and one of the first big studies that was done, and we'll just text on it, is sponsored by 9 state DOT agencies. It was the Montana State study under very soft soils. No input from manufacturers. And sponsored, so I don't know, we got anybody from this territory in it? Nebraska, Missouri, South Dakota, maybe?
Maybe, yep.
Maybe Wyoming?
Maybe.
You guys cover that footprint now, so you guys go out there.
Yep, we go all the way from the Rockies out to the Pacific Northwest.
So, and I go all the way down in Oklahoma, and based on this study, they started using this product quite a bit. So it was nice to see them actually take the research and then say, okay, I like the way that looks. And they trafficked it until it came out. And the RS580i at the end came out as the highest achieving product. The greatest amount of passes, the lowest amount of deformation, and the lowest amount of deformation at any point throughout. And so this was one of the things that came out of the study, because like a non-woven was on this and fared okay. Why is separation so important? And I know I'll have to speak from everybody unless Bill wants to interject. What are we looking at here in this picture?
That next slide will tell the story that I tell because I live on a gravel road and I have to keep adding gravel to my driveway. I have no separation in my driveway.
Yep. Oh, so next one. But yeah, so after this test was done, they went and kind of exhumed sections. These lines here, nobody can probably see my arrow here, can they, Bill?
No.
Okay, so the pink red line that's going through the section, that is the area where the fines or the soil from underneath the fabric or geogrid has migrated their way all the way up into the base rock section. So an 8-ounce non-woven performed okay on this test because it was able to keep rock above it and fabric below it for the time being of the test. Eventually, this would have been too much pressure and that would have ruptured. But it was able to separate it. Where some of the geogrids did worse is due to the fact that the fines kept where to go. Kind of goes back to, hey, if you really like a grid for interlock and confinement and you like the way it stabilizes, great. But you really got to look at the underlying soils and what you're working with to keep that keep those from intermixing. RS on the other line takes that huge frictional, huge strength, separation, confinement, and does it all in one step.
And your next slide is the one that really tells the story for me, that old adage.
Yep. Yeah, pretty obvious, right? 10 pounds of stone placed on 10 pounds of mud is 20 pounds of mud.
Yep, that's true.
That is true. Thank you, Bill. Here's kind of a test pit we've looked at. This is when you get on real poor soils. This is probably CBR of about 1 that we kind of do some tests when we do some training of people and bring them out to see our products made. This is our pit. And you could see RS, Geogrid, and then a non-woven on the far side. And we go out and you walk on them just to see how they interact with some of these conditions.
I love that. You had me down there in Georgia, and I did that at Mirafi U. We had that CBR of 1 when we first stepped in, but then it just got better as we made our way across.
Yeah, and it really is something walking on the different products and what happens. You know, some push all the way in, and then others you step on and just water dissipates through the top of it. Sorry, I'm having to hit like multiple buttons for my dual screens and some.
Yeah, so we're at 109.
Yep. So here's what we're looking at here: geotextile separation. These next two, and you know what I briefly touched on earlier, are very important. So say we're at that CBR of 1.5 or 2. So a CBR of 2, your pickup truck might barely be running it, but we're going to go load rock, a 10-inch rock section, right? So what this tells you at that CBR of 2, which isn't terrible, like we said, we're not sinking, but if you scroll all the way to the left, that means you're losing 20% of your rock is just getting lost while building the road without any sort of separator between the fabric and the grid, or your parking lot, or your laydown area. Well, what does that matter? Yeah, I put 10 inches, so great, I only have 8 inches. Well, looking at this, if you lose that 20% of your road, of your structural carrying capacity, and you start looking at what a 6-inch asphalt looks at, like over 8 inches of rock versus 10-inch, we're now looking at, we've lost up to 50% of our road capability. So when roads are supposed to be 20, 30 years and they're lasting 10 or 15, this could be a huge culprit to what is causing those conditions. I need to be. So this is a term that coined out a couple years ago, and I absolutely loved it. So if we're talking about building roads or doing anything, this perpetual aggregate base, right? It's the combination of a common unbound aggregate base and an effective separator to establish a permanent foundation. Okay. Permanently keeping everything that you bought and put on top of the fabric above it and not losing it through the fabric or that intermixing. Dramatically lower the life cycle costs of the road. But here's some of the good stuff. Separates dissimilar material. Your road never requires full depth reconstruction again. So mill and overlay programs can truly work because we haven't destroyed them at the subgrade, right? Everything we said, keep the rock you buy above the fabric and keep the subgrade below the fabric. Separation allows the use of freer draining base aggregates. Stabilization, confinement, restraint. Oh, that wasn't supposed to happen. And then confinement stabilizes and strengthens the subgrade's role. The subgrade burying capacity can be increased by up to 80%, or typically increases to 80% by just incorporating some sort of high-strength geosynthetic or fabric and keeping dissimilar materials from intermixing. So here's kind of a local case study. This is about as bad as it gets. 6-foot ruts. And if I can go back one. This is a project we did with ASP over in Missouri. Wow. Bill, I think we got a little. Yeah.
I'm not touching anything. What is it supposed to be a video?
No, just got a mind of its own for a minute. It kind of froze up, so we're good. And I was called out the day before, and a guy had sunk to his hips trying to stake some of this area. So they pull him out with a rope and a track hoe. And we talked about numerous things and finally said, it was blow counts of 0 past 30 feet. So there was no bottom to this. And so we had to put this fabric in, and they were convinced, the contractor was, that it was not going to work. As soon as we got it, started kicking and rolling it, and it was a nice situation that we were able to, it was very hard to walk on. So this is how you had to do it. Very soft, very poor. Like I said, CBR of 0. We were able to shoot rock onto this site and just get building immediately. There you see some overlaps. Went with the 3-foot overlap here. Didn't really need to because of the belt shooter. Typically, you, like I said, spread that rock. But this project has actually led to a relationship with this contractor. We're now traveling with him around the country, working on some huge plants where they are big steel companies using us exclusively with them to build all their plants because they had so much stabilization success with us. So now that we talked about RS, the next evolution from that is you take a product that can help with moisture. And I'll probably, Bill, what time I need to be done? 120?
You can go to 125 would be good.
I just want to be able to show a few things on this and some local projects installation. So now we take a product that's very similar constructability wise to the Mirafi RS, that's super strong fabric that does everything. And we've added the ability to move water. And so the biggest problem with most structures are drainage. And how do you move water through it? And understanding with any structure, the threat is water within it. Accelerates the deterioration of the assets, loss, risk, takes away time and resources. And I'm going to move a little quicker at these because I want to make sure we get to some things.
Well, we don't have a Q&A going, so that'll just be for me. So you're doing great.
Okay. And moisture costing money. And what does it really do? I'm sure Kansas City, this whole Midwest has terrible pothole problems. But $4 billion annually, which translates to $600 a driver. I remember a couple of years I was giving this similar type presentation talking about this, and I literally, as we're going, got hit by a rock coming through a pothole and put a crack in my windshield mirror on the way to, my front window on the way to give it. So I'm very familiar with what rocks on the road and potholes can do. So here's the moisture management system, kind of in a schematic and what it can do that way.
I love this graphic. It's amazing.
And then here's a video kind of showing what it can do. So, and then this one, in my opinion, is even a little bit better. Kind Come on. Shows the water making its way down, hitting the fabric, or water from the top down or below, hitting the water, hitting the fabric, and then removing itself. And so the big key to this, guys, now we're looking at a product that separates materials. It provides filtration and separation. It provides reinforcement and confinement. It is a very, very strong frictional product like the RS, but there's nylon wicking yards woven into this pattern that pulls water from unsaturated conditions before the soil can fully break down, or for your base rock gets real wet and breaks down strength-wise and pulls it out. The one caveat installation here, water has to have somewhere to go. So if you would just bury this in a curb and gutter, it would effectively be RS580I. But if you give it a chance for evaporation to work, then it can continue to pull. How much can it continue to pull? You ask, Bill? Well, up to 1.4 gallons per minute, gallons a day per linear foot. So every foot of exposed edge is 1.4 gallons. So that means a roll is 375 gallons, and 1 mile is 15,000 gallons a day. Pulling from not only the subgrade, but the sub-base material. So the water, and what's critical here, it does not work like a drain that gets full saturation and then the water bursts through. This continually moves moisture. So as anything draws near, it moves out. Why is that important? Because at full saturation, the soil breaks down. You get full saturation, you get a weaker soil, loss of shear strength, and that CBR that's a 3 becomes a 2 and worse. So this keeps it at more optimal levels. So how was this developed? This was the initial road, ice road truckers, if you've ever seen this before, and you'd come over this hill and the truckers would hit the brakes and they'd rut and get this every single year. And so this was, I don't know what's going on, Bill, but I have dates that should be showing up on this stuff.
It's working. It's everybody else sees it. We all see it. Your toolbar's just covering it up.
Gotcha.
The viewers, the attendees are seeing it. So am I.
Perfect. Okay. And they came back next year. So every year they had to rebuild this, and they put this in, monitored it, and every year they've come back and it's not. And so you see there's a rut that is developing immediately before the staking of where the H2RI was. So the DOT was so happy with it, they started doing numerous other projects with it. And you can see here's a real prettier one in Alaska. Here's post.
We get asked about that edge treatment right there, because that was one of the first ones you didn't really do anything specific with the edge. You just daylighted.
Correct. You see the amount of the daylight and the moisture.
Yeah.
Right. And then here's even a little more, this was years ago over on the St. Louis side, but here's Boone Bridge. Put this in, very hot day, probably August-ish. Well, I know it was August, September, something like that. And we got a big rain event that night after we installed this for the approach. We came back out that next day, and you could see it was still moving and sucking water out from underneath either the rock section or the subgrade and bringing it out to the sideline. Everything else was bone dry because it was so hot that next day. But from where it had rained, you could still see the movement of water. Now, one of their engineers said, this was the project when it got passed, that you could see a lake in the ditch for MoDOT over. I don't know if all of that water can be attributed, because it's not going to look like a fire hose, guys. It's a constant drip of it hitting the soil, but it's nonstop movement that continually gets it from out underneath the structure. So like I said, a 2% reduction. This was through Kansas, did the testing on what does it do to your rock section. Well, it's a good 2% reduction in the amount of water that's in your base rock. What does that mean? That means an increase in your resilient modulus by up to 150%. So 150% stronger your rock becomes, which then correlates to a greater than 50% reduction in permanent deformation of the stone. So just with that 2% there alone, it's a huge increase in the reduction of deformation. This is not even taking into account, this is only moisture, guys. This is only pulling out the water. of the rock. It's not talking about draining of the subgrade, pulling water out of a subgrade, and it is not talking about separation, reinforcement, and confinement, and everything else this fabric's doing. So the amount of things it is doing within a section, it's almost a living component by its ability to permanently move the moisture out of it while separating and reinforcing those common materials, discommon materials. So what's it look like? Underneath the light, there's some testing we did underneath the black light, and you'll see the fabric with the yellow. It's just water as it pulls it out. And then what if there's a hump or undulations in the subgrade? Takes it right up and over it, continues to move it. So if we do the similar thing with a, say, a non-woven can definitely saturate.
And you can see this happening during installation where a contractor might get a wrinkle in the fabric. They don't pull it tight. There's a little bit of a fold.
Yep. So with this here, the difference, it would just be able to get wet and move it. It's not really actually moving it. The water's moving as the fabric is saturating. But if it ever reaches a place, you would just get an undulation and it would stop and it would start pooling without that. So that shows its ability to actually move it up a vertical grade. So I'll just wrap it up with a couple problems.
Shows the difference that wicking can make. I didn't mean to talk over you, but that wicking is huge. There's the clothing industry has invested billions of dollars in the wicking idea.
Yeah, and just to think something it could do under a road for 20 years to constantly wick.
Yeah.
And actually 50, 70 years, whatever. So the Kansas DOT actually had done some testing and became big proponents of this. And so we've started using it on some projects there. And so what they were finding is they'd like to use a cement treated base for stabilization, non-wovens for separation, and under drains, which they found that has always clogged. And actually, and a more expensive rock that doesn't drain as well. So they thought, hey, could we use an H2RI? And now it hasn't eliminated everything yet, like we think it could, but they wanted to start testing it. Hey, can we use it instead of under drains? Can we now use a less expensive rock that doesn't have to be as drain as well, like an 1.5 inch or 3/4 inch minus, but basically I forget what the Nebraska one's called. It's called AB3 in Kansas or Type 5 in Missouri. Can we use a less expensive rock that doesn't have to be as open graded so it can drain? All of these things, and they did some testing and found yes. And so here's what a really nice looking job in Kansas looks like. And this shows all the aspects of construction. So you can see the overlaps of the H2RI, but you'll see the back dumping of rock. These guys are doing a great job of staying off, in certain areas here. But this kind of, you'll see the full aspect of I really hope yours is playing better than mine.
The audio's working.
Yeah.
Talk over it if you want.
Take pictures for the 1,000 words here, Bill. But this is pretty nice operation they got. One of these barges. The fabric comes on a core. So here they can run this, pour it through, load it up, and reel it back. Like I said, most operations are not this sophisticated and this smooth. These guys are really good, big contractor in Kansas. And they can install a whole pot of it in a short time. But yeah, I mean, this is highway building. First you saw the two dudes kneeling and trying to kick and roll out, 4 walls in a matter of a day and a half or 2 days. This shows how much simpler it can be in the right application.
There you go.
So yeah, we've done multiple jobs there. Another ASP webinar we did, the track at K-State University was delaminating, and they had huge issues. He was worried about water moving up within the track section. And he wanted to use the HRI not for any other property, but besides its wicking. So we did that a couple years ago where we tied it into a collection system at the bottom, the inside, all the way around the track. And then did that. And yeah, it's been a number of years and still haven't.
That's beautiful.
Yeah, went really well at the time. It's still going great. And I'd say that's gotta be 4 years ago. So
We need to take Todd Noble out there and see if he can set a new personal best.
Yeah.
Track speed.
And I know that we've done numerous tracks. I know more tracks out west we've done as well, where people have used it for very similar. So yeah, just wrapping up, where should you think about using an HRI? High water table is number one. Anytime the water table is rising and you could get rid of it, do it. Expand excess moisture in your base and sub-base, moisture in your subgrade, expansive soils, the ability of this fabric to mitigate moisture differential and swell by spreading the water. It really wants to take things from where they're wet to where they're dry. So even there's a continuous moisture management system that's going on under that soil. Frost susceptibles, just to be able to move water before it can turn into ice cubes, to ice lenses, to things that melt and leave giant potholes in your ground, in your roads, and anywhere the moisture can affect a civil structure. So that's it. We're real close.
We are good on time. I'll tell you, on the Q&A side of things, I have some frequently asked questions that we get. You've already addressed them. One of them was, can you use the software, the design software, for unpaved as well as paved? And yes, there's an option in there to select unpaved.
Yeah, but you should say, if you Google, it's Tencate Geosynthetics, but it's Miraspec, like Mirafi, or not Miraspec. Miraspec. What am I saying?
Yeah, you're right.
It's the Miraspec software, right?
Yeah, it is. It is, and it's.
I just had a brain.
And they can find it through our contact info as well. I'll take over the screen sharing, I guess.
Okay.
I'm going to end with this too. So Jim works closely with our folks, and he says ASP a lot because that's mostly who he works with. But all of our branches work with these guys and are willing to answer questions. Our website, aspent.com, really covers all the others. Any of these websites point to the same thing. It's the same parent website. And so we'll have links as well to the Tencate Mirafi info, and they're going to do an awesome job. Jim mentioned Solmax earlier, and we've known about that for a while. That evolution's coming this year. New logos, branding. We're doing the same thing. You can see some different fonts. Our logos are all going to change, not because we're changing our companies, because that's the trend right now. Everybody's trying to dial in on this identity that captures a lot of the different resources they have. So with Solmax being a big company, they're not going to be harder to deal with. They're just going to have more resources, and they're going to have more power behind what they do. Everything that we do with you guys is going to stay the same. We're assured and confident in that. The other thing we get asked is, I think I wrote myself a note about it, Jim, to ask you. Sorry to make noise with my notebook. The Cliff Notes, the resource. This is something that our sales guys ask me sometimes. I told you that I don't, like, when I over design my own personal projects. I'll give you another example. I built a retaining wall. I could have used Uniaxial. I went to BXG 120. I just kept increasing what I was going to use. Why? Because I want the best, and if I have some roll left over, I could use that under some of the parts of my driveway building up to my patio where I didn't need the separation on the dry side, the high side. I just wanted some of that rock reinforcement. I'm a huge champion for our RSI product under pave drain, for example, under permeable pavers. We like to line the entire chamber, bottom and sides, with the high performance geotextile. We're right at 1:30. Jim's available to continue lunch and learns with you, so am I. We would love to have this lead to that. So anybody that has questions, look for the survey that Madeline Drury is going to send from our company. After that survey, we'll verify your contact information. We'll send out the PDH certificate, and we'll include some of those simple Geo 101s. You have some resources that are good for that, don't you, Jim? The little matrix that shows which product to select for which application.
Yeah, absolutely.
All right. With that, thank you, Jim. Safe travels, and I look forward to seeing you in Omaha.
All right. Thank you, everybody.
Thanks, guys.